Hey there, science fans! Welcome back to another exciting episode where we unravel the mysteries of the tech world. Today we're diving into the fascinating world of electronics, a realm filled with tiny components that make our modern lives possible. Specifically, we're going to explore a cool and incredibly useful device called a DC to DC buck converter. This little gadget plays a crucial role in many of the electronic devices we use every day. So, what exactly is a DC to DC buck converter? In simple terms, it's like a voltage transformer, but for direct current, DC electricity. It takes a higher voltage and steps it down to a lower, more usable voltage. Imagine you have a battery with a certain voltage, but your gadget needs a lower voltage to work properly. For instance, your smartphone might need 5 volts to charge, but your battery provides 12 volts. That's where the buck converter swoops in. It efficiently converts that higher DC voltage into a lower DC voltage, ensuring your device gets just the right amount of power it needs. It does this by using a combination of inductors, capacitors, and switches to regulate the voltage. The result is a smooth, stable output that keeps your electronics running safely and efficiently. Pretty neat, right? Think of it like adjusting the water pressure in a hose. You can control how much water flows out, ensuring it's just right for the task at hand. You wouldn't want to water your delicate flowers with a fire hose, would you? The same principle applies to electronics. Too much voltage can damage sensitive components, while too little can make them underperform. The buck converter acts like a pressure regulator, ensuring your electronics get the right voltage without getting fried. It's an essential component in power management, making sure everything runs smoothly and efficiently. So next time you charge your phone or use any battery-powered device, remember the unsung hero inside, the DC to DC buck converter, quietly doing its job to keep your gadgets powered up and running perfectly. Thanks for joining us on this journey into the world of electronics. Stay curious, and keep exploring the amazing technology that powers our lives. Now let's peek under the hood and see the magic happen. A buck converter relies on the principles of switching and energy storage to do its job. It's all about turning the flow of electricity on and off very quickly. Picture a fast blinking light. A buck converter rapidly opens and closes a switch, kind of like that blinking light. When the switch is on, electricity flows through a special coil called an inductor. This inductor is like a temporary energy storage tank. When the switch is off, the energy stored in the inductor is released, providing a continuous flow of electricity even though the switch is open. Let's meet the key players in a buck converter team. First up, we have the inductor, our energy storage hero. It's a coil of wire that resists changes in current flow. Next, we have the capacitor, the smoothing superhero. It acts like a reservoir, storing energy and releasing it to even out any voltage fluctuations, creating a stable output. Then there's the switch, the traffic director. It rapidly opens and closes, controlling the flow of electricity. Finally, we have the diode, the one-way valve. It ensures that electricity flows in only one direction. The inductor is like a coiled spring. Just as a spring can store mechanical energy when it is compressed or stretched, an inductor can store electrical energy in the form of a magnetic field. This analogy helps us understand the fundamental principles of energy storage in inductors. When you compress a spring, you store potential energy, right? This potential energy is released when the spring is allowed to return to its original shape. The same concept applies to inductors, but instead of mechanical energy, they store and release electrical energy. Similarly, when electricity flows through the inductor, it builds up a magnetic field, storing energy. This magnetic field is essentially the inductor's way of holding on to energy, ready to release it when needed. The strength of this magnetic field depends on the amount of current flowing through the inductor. When the switch opens, the magnetic field collapses, releasing the stored energy. This release of energy can be harnessed to power other components in a circuit, ensuring a smooth and continuous flow of electricity. This energy then flows to the output, providing a continuous current even when the switch is off. This is crucial in many electronic devices as it helps maintain a stable voltage and current, preventing interruptions in the device's operation. Think of it like squeezing and releasing a sponge filled with water. When you squeeze the sponge, water flows out, and when you release it, the sponge absorbs water again. This cyclical process is similar to how inductors store and release energy. This cycle of storing and releasing energy is what allows the buck converter to step down the voltage. By carefully controlling the timing of the switch, the buck converter can efficiently reduce the voltage to the desired level, making it suitable for various applications. The longer the switch is on, the more energy is stored in the inductor, and the higher the output voltage. This principle is key to understanding how buck converters and other power electronics manage energy to provide the necessary power levels for different devices. Section 5. The capacitor's contribution, smoothing the output. Now let's talk about the capacitor, the master of smoothness. Remember those annoying ripples you sometimes see in water? We don't want those in our electricity. The capacitor acts like a filter, smoothing out any voltage spikes or dips. It stores energy when the voltage is high and releases it when the voltage is low, ensuring a nice and steady output voltage. Imagine a bumpy road. The capacitor is like the shock absorbers in your car, smoothing out the bumps and providing a comfortable ride for your electronics. Section 6. Switching it up. The role of the switch and diode. Time to shine a light on the switch and diode. The switch is like a gatekeeper controlling when electricity flows through the circuit. By rapidly opening and closing, it creates the pulses of energy that the inductor stores. The diode acts like a one-way valve, ensuring that the current only flows in one direction. Think of it like a door that only swings one way, preventing any backflow. The speed at which the switch opens and closes determines the efficiency of the buck converter. Faster switching means less energy is wasted, making it more efficient. Section 7. Buck converters in action real-world applications. Buck converters are everywhere in our electronic world. They're the unsung heroes powering our smartphones, laptops, LED lights, and so much more. Inside your smartphone, buck converters are busy stepping down the battery voltage to power different components, like the screen, processor, and memory. They're also used in chargers to convert AC power from the wall outlet to DC power for your phone. In LED lights, buck converters regulate the current flowing through the LEDs, ensuring they operate at the right brightness and don't burn out. They're essential for making LED lights energy efficient and long-lasting. Section 8. Efficiency matters. Advantages of buck converters. One of the biggest advantages of buck converters is their efficiency. Unlike traditional linear regulators that waste energy as heat, buck converters can achieve efficiencies of over 90%. This means that less energy is lost as heat, resulting in longer battery life for portable devices and lower electricity bills for home appliances. Plus, less heat means cooler operation, which is good for the longevity of electronic components. Buck converters are also very versatile. They can be designed to handle a wide range of input and output voltages and currents, making them suitable for a variety of applications. Section 9. The future is bright buck converters in modern technology. As technology advances, the demand for smaller, more efficient, and more powerful electronic devices continues to grow. This trend is driven by the need for portability, energy efficiency, and enhanced performance. Consumers and industries alike are constantly seeking devices that can do more while taking up less space and consuming less power. Buck converters are at the forefront of this revolution, enabling the development of cutting-edge technologies. From electric vehicles and renewable energy systems to wearable electronics and medical devices, buck converters are essential. They help in reducing the size and weight of power supplies, making it possible to integrate them into compact and portable devices. Buck converters are playing a crucial role in shaping the future. Their efficiency in converting higher DC voltages to lower ones without wasting energy is a key factor in their widespread adoption. This efficiency not only conserves energy, but also extends the battery life of portable devices, making them more reliable and user-friendly. Their ability to efficiently convert and regulate DC voltage makes them indispensable in a wide range of applications. Whether it's in the automotive industry, renewable energy sector, or consumer electronics, buck converters are the unsung heroes that ensure our devices function smoothly and efficiently. So the next time you charge your phone, remember that a buck converter is working to ensure your device gets the right amount of power without overheating or wasting energy. When you turn on an LED light, it's the buck converter that helps in providing the precise voltage needed for optimal performance and longevity of the light. Or when you marvel at the latest technological gadget, think about the intricate power management systems inside, often driven by buck converters, that make these innovations possible. Remember the humble buck converter, quietly working behind the scenes to make it all possible. These small but mighty components are the backbone of modern technology, ensuring efficiency, reliability, and performance in our everyday devices.